Hey everyone, let's get one thing straight right out of the gate. You absolutely do not need to be a genius to start coding. Welcome to this explainer. Over the next little while, we're going to totally demystify programming. We're taking you from absolute zero to writing real, actual functioning Python code. No prior experience? No problem at all. Just follow along with me. Python is actually one of the most popular programming languages on the planet. I mean, it literally powers heavy hitters like YouTube, Instagram, and Spotify. So whether you're looking to build websites or just, save some time by automating boring tasks, it is the perfect first language. Our agenda today covers setup and first program, variables and user input, type conversion and strings, math and logic, and finally loops and lists. Let's jump right in. All right, section 1, setup and first program. Before we can build the house, we gotta gather our raw materials, right? Step 1 is grabbing the language itself. You'll download the latest version straight from python.org. Now, pay super close attention here, especially if you're on a Windows machine. You absolutely must check the box that says Add Python to Path during the installation. Seriously, if you miss this, your code just won't run properly. Okay, step 2 is grabbing a code editor. PyCharm Community Edition is totally free, it's incredibly powerful, and highly recommended. Once you've got that installed, create a new project, and inside that, a file named app.py. Boom, there's your new blank canvas. Now, it's time to lay your very first brick. In that app.py file, type print, open your parentheses, open a quote, type hello world, close the quote, and close the parentheses. So what's happening here? Well, that word print is a built-in Python function. It just takes whatever you hand it and slaps it onto the screen. And that text inside the quotes, in programming, we call that a string. When you actually run this file, a little window at the bottom, called the terminal, is going to pop up, and you'll see the words hello world. Honestly, congratulations. You've just executed your very first Python program. Moving right along to section 2, variables and user input. This is where our programs stop just being static text and actually start interacting. Think of a variable kind of like a labeled box in your computer's memory. If you type age equals 20, age is the label slapped on the outside of the box, and 20 is the data packed inside. So if you print age, it shows 20. But here's the catch. Because Python reads your code sequentially, top to bottom, you can change it. If you type age equals 30 right below that first line, that exact same box tosses out the 20 and holds 30 instead. Now, as you're packing these virtual boxes, you're going to use a few common data types. You've got integers, which are just your standard whole numbers. You have floats, which are numbers with decimals. Strings, which we've already touched on, are used for text. And finally, Booleans. These represent super simple true or false states. Oh, and a quick warning for beginners. Python is strictly case sensitive. If you want to use a Boolean, true absolutely has to be written with a capital T. A lowercase t will instantly throw an error. Programs are infinitely more fun when they actually talk back to the user. We do this using the input function. By typing input followed by a question like, what is your name? Python will literally hit pause and wait for the human to type something into the terminal. It's kind of empowering to make the machine wait on you, right? Whatever gets typed in is then stored in our variable called name. Then, on the next line, we use the print function to say hello and use a plus sign to stick the name variable right onto the end of it. By the way, using that plus sign to link text together, that's called string concatenation. Okay, on to section 3, type conversion and strings. Let's clear up a super common beginner hurdle right now. A classic trap happens when you try calculating someone's age. You ask the user for their birth year, try to subtract it from the current year, and bam, the program crashes. Why does that happen? Well, it's because the input function always hands you back a string of text. You literally can't subtract the word 1990 from a number. But the fix is actually really simple. You just wrap the birth year variable in the built-in int function. This converts that string of text into a proper integer number, and suddenly your math works flawlessly. You can also use float, stir, or bool functions to easily convert between other types too. Before we start really messing around with strings, let's just lock down our definition. A string is basically any sequence of characters stuffed inside quotes. Seriously, it doesn't matter if it's letters, numbers, or a bunch of weird symbols. As long as it has quotes around it, Python treats it as a string of text. Strings are incredibly powerful because they come loaded with built-in tools called methods. Imagine a user types their name in messy, mixed-up uppercase and lowercase letters. Just adding .upper to it instantly capitalizes the whole thing. .lower makes it all lowercase. .replace acts kind of like a magic wand, letting you easily swap out specific words right in a sentence. And the best part? These methods don't destroy your original string. They actually generate a brand new one for you. You can also use the in operator to check if a specific word exists within a string, which spits out a simple true or false Boolean. Section 4. Math and Logic. We've stored data, so now let's make our programs smart enough to make some decisions. First up, Python handles standard math exactly like you'd expect, but it does have a few special tricks up its sleeve. A single slash gives you standard decimal division, but a double slash performs integer division, basically dropping the decimal entirely. Need to find a remainder? Use the percent sign, which we call the modulus. And for exponents, it's a double asterisk. Just keep in mind, Python follows the normal order of operations from your old math classes, but you can always throw in parentheses to force the exact order you want. Beyond basic math, we often need to compare values. We use the less than symbol, less than or equal to, the double equals sign to check if two things are exactly the same, and the exclamation point equals, which just means not equal. Here's the key takeaway. Whenever you use these comparison operators in Python, they will absolutely always evaluate down to a simple Boolean response, just true or false. Imagine we're writing some temperature logic to dictate what our program should actually do. If the temperature is greater than 30, it prints hot. If it's not, it checks the elif statement, which is just short for else if, to see if it's over 20, and prints nice. If literally neither of those are true, it falls back to the else condition at the end and prints cold. The beauty of this structure is that only one block of this code will ever run, totally dependent on the conditions you set up. Honestly, this right here is the absolute foundation of complex programming. All right, our final section. Section 5, Loops and Lists. This is how we automate repetitive tasks and manage complex data. A loop lets you run the exact same block of code over and over without having to manually type it out 100 times. Let's look at a while loop. We start by setting a variable, I, to 1. The code basically says, while I is less than or equal to 5, print I, and then add 1 to I. So it prints 1, becomes 2, prints 2, becomes 3. It automatically loops around until that condition is no longer true, cleanly printing the numbers 1 through 5. A for loop is just another way to automate repetition, but it's specifically designed to iterate over sequences. One incredible tool to pair with it is the range function. You can feed range a start number, a stop number, and a step. So range starting at 5, stopping at 10 with a step of 2 gives you absolute fine control. When that loop runs, it'll print 5, skip to 7, and then 9. Just think about how much time this saves compared to writing out massive sequences by hand. It gives you incredible precision for automation. But hey, what if we want to loop over actual data, not just numbers? That's exactly where lists come in. A list stores multiple items in a specific order. You can access individual items by their index number. But remember, programmers start counting at 0. You can also slice the list to grab a whole chunk of it at once. And lists come with super powerful built-in methods to easily manage your data. You can use .append or .insert to add items, .remove to delete them, or .clear to wipe the entire slate completely clean. Finally, you really should know about tuples. A tuple is very similar to a list, but it has one massive game-changing difference. It is immutable. That basically means once you create a tuple, you cannot change it, no matter what. You can't append to it, you can't remove things, and you can't alter the items inside. So why does this matter? Well, you use tuples when you have a sequence of data that absolutely must remain constant throughout your program. It basically ensures that no accidental changes can occur while your code runs. Wow, we have covered an incredible amount of ground today. From getting your Python environment all set up, to manipulating variables and strings, all the way to controlling the flow of your program with loops and lists. You literally have all the tools you need right here in this explainer to start building real mini projects, like a calculator or a weight converter. But here is the real question I want to leave you with today. Now that you hold the power to automate decisions, manipulate data, and command your computer to do the heavy lifting, what boring, repetitive task in your own life are you going to automate first? Keep coding, and I'll see you next time.